Have you ever wondered how we can quantify the abstract or the strange? These are concepts that, at first glance, seem to slip through the fingers of concrete definition, preferring to exist in the realm of the subjective and the intangible. But what if we could pin them down, turn them over in our hands, and examine them under the cold, hard light of numbers and equations? The task at hand is to create a mathematical framework to measure the abstractness, or the high strangeness of concepts, objects, or phenomena. It's a fascinating challenge that requires us to first define what we mean by abstractness and strangeness in quantifiable terms. When we talk about abstractness, we're referring to the degree to which a concept or object is removed from concrete physical experiences and specific instances. The higher the level of abstraction, the more it involves generalization and the less it relies on physical or tangible examples. On the other hand, when we mention strangeness, we're considering the degree to which a concept or object deviates from common experience or expectations. Something very strange would be highly unexpected or unfamiliar to most people. The goal here is to create a system that can measure these qualities. We want to propose several dimensions, such as the level of generalization, familiarity index, conceptual distance, and novelty score, and then attempt to create a formula that incorporates these dimensions. But it's not as straightforward as it sounds. The formula would need to be calibrated against a wide range of concepts and phenomena independently ranked for abstractness and strangeness by experts and laypeople. Through statistical analysis and refinement, the weightings, and perhaps the structure of the formula itself, could be adjusted to better reflect the complexities of these qualities. The challenge is incredibly fascinating, and while there's no widely recognized mathematical system for this, today we will explore a conceptual approach to invent such a system. So buckle up and prepare for a journey into the abstract and the strange as we attempt to quantify the seemingly unquantifiable. Before we delve into the mathematics, we need to understand what we mean by abstractness and strangeness. In the realm of ideas and concepts, abstractness could be defined as the extent to which a concept or object is removed from concrete physical experiences and specific instances. Think of it as a level of generalization. The higher the level of abstraction, the less reliance there is on physical or tangible examples. On the flip side, we have strangeness. This could be perceived as the extent to which a concept or object deviates from what we consider common or expected. The stranger something is, the more unfamiliar or unexpected it appears to most people. Now, let's put these two ideas together. Imagine you're handed a round rubber object. If you're told it's a ball, that's not very abstract or strange. It's a common everyday item most of us are familiar with. But what if you're told that the ball represents the universe, and we're all just tiny particles inside it? Suddenly, it becomes more abstract and perhaps a little strange too. See, abstractness and strangeness can be seen as two sides of the same coin. They both deal with how we perceive and understand our world, but from slightly different angles. Abstractness looks at how much we need to generalize or remove from the concrete to grasp a concept, while strangeness deals with how much a concept deviates from our usual or expected experiences. These definitions are not set in stone. They are merely starting points, launching pads for deeper exploration. They give us a framework to start thinking about these concepts, but there's always room for refinement, for subtlety, for nuance. Now that we have a better understanding of these terms, we can start considering how to measure them. To measure abstractness and strangeness, we need to propose some dimensions. Now, let's dive into the 4 dimensions we could use to measure these elusive qualities: generalization level, familiarity index, conceptual distance, and novelty score. First up is the generalization level. Think of this as a measure of how universal a concept is. If an idea applies in many different fields or contexts, it has a high generalization level. For instance, the concept of change is universal, applicable from physics to philosophy, thus scoring highly on this dimension. Next, we have the familiarity index. This is a measure of how well-known or intuitive a concept is to people outside its field. The less familiar or intuitive a concept is, the lower its familiarity index. For example, Quantum mechanics is a field that's often considered quite unfamiliar and counterintuitive to those outside of physics. Hence, it would score low on this dimension. The third dimension is conceptual distance. This measures how far removed a concept is from everyday, tangible experiences. The more a concept veers into the theoretical realm, the higher its conceptual distance. A concept like time, for instance, is abstract and somewhat removed from our physical reality. Thus, it would have a high score in this dimension. Lastly, we have the novelty score. This gauges how new or unique a concept is. If a concept represents a significant leap from existing knowledge or understanding, it has a high novelty score. A revolutionary idea in technology or a breakthrough scientific theory would score highly on this dimension. These four dimensions, generalization level, familiarity index, conceptual distance, and novelty score, are our proposed metrics to quantify the abstractness and strangeness of concepts, objects, or phenomena. Each dimension helps us capture a different facet of what makes something abstract or strange. Remember, these metrics are just a starting point. They are the building blocks we'll use to construct a mathematical framework to measure abstractness and strangeness. With these dimensions in place, we can start to construct a mathematical framework. The next step is to translate our dimensions into a mathematical formula. Let's venture into the world of numbers and equations. We have our dimensions: generalization level, familiarity index, conceptual distance, and novelty score. Now it's time to bring them together. Imagine a balancing scale, with our dimensions as weights on one side. On the other side, we have abstractness and strangeness. Our goal is to balance this scale, but how much should each dimension weigh? Enter our weighting coefficients, A, B, C, and D. These coefficients determine the importance of each dimension in the overall abstractness and strangeness score. The higher the coefficient, the more weight that dimension carries. Here's our proposed formula. A equals A times generalization level, plus B times the inverse of familiarity index, plus C times conceptual distance, plus D times novelty score. Why the inverse of familiarity index? Well, remember that less familiar concepts have a lower familiarity index, but contribute more to the abstractness and strangeness score. Hence, we invert the familiarity index to reflect this relationship. What about the coefficients? How do we choose A, B, C, and D? This is where the art of calibration comes in. We would adjust these coefficients based on further research into how these factors interplay and contribute to our perception of abstractness and strangeness. Now, it's important to remember that this formula is a starting point. It's a simple linear combination, and in reality, the relationships might be more complex. There could be interactions between the dimensions, or other factors we haven't considered yet. Moreover, this formula doesn't capture the full breadth of human thought and creativity. Abstractness and strangeness are nuanced, subjective qualities. They can't be fully quantified by a single formula, but this formula gives us a way to start thinking about these qualities in a more structured, systematic way. This formula, while simple, provides a starting point for measuring these complex concepts. And with that, we move on to the next step: calibration and testing. Of course, any formula needs to be tested and calibrated. Now that we've proposed a formula for measuring abstractness and strangeness, it's time to put it to the test. Let's imagine a collection of concepts and phenomena, each independently ranked for their levels of abstractness and strangeness by a wide range of experts and laypeople. We would then use these rankings as our benchmark to calibrate our formula. To do this, we'd need to dive into the realm of statistical analysis. We'd apply our formula to each concept and phenomena in our collection, calculating an abstractness and strangeness score based on our proposed dimensions: the generalization level, familiarity index, conceptual distance, and novelty score. Next, we'd compare these calculated scores with the independent rankings. Do they match? If yes, then our formula might be on the right track. If not, then it's back to the drawing board. Now, let's consider the possibility that the formula might need adjustments. Perhaps our weighting coefficients, the A, B, C, and D in our formula, need tweaking. Maybe one dimension contributes more significantly to the overall score than we initially thought. Or perhaps the relationships between the dimensions aren't as linear as we assumed, requiring us to rethink the structure of our formula entirely. This is where refinement comes into play. Refinement is the process of making changes and adjustments to improve the formula. We might adjust the weightings, tweak the structure, or even introduce new dimensions. It's all part of the iterative process of scientific discovery, a constant cycle of proposing, testing, refining, and testing again. And through this cycle of calibration and testing, our formula is slowly honed, sharpened, and refined. It's an ongoing process, one that might continue indefinitely as we encounter new concepts and phenomena, or as our understanding of abstractness and strangeness evolves. Through this process, we can refine our formula to better capture the essence of abstractness and strangeness. We're not just creating a formula here. We're creating a tool for understanding and exploring the fascinating world of abstract and strange concepts. Once calibrated, this formula opens up a host of interesting applications. Imagine being able to quantify the abstractness and strangeness of a brand new scientific theory. This could provide a unique perspective on groundbreaking ideas, allowing us to appreciate their novelty and innovation in a quantifiable way. Consider the world of art. This formula could be used to evaluate different artistic movements, offering a new lens through which to understand and appreciate their abstractness and strangeness. What if we could measure the shift from realism to cubism using our abstractness and strangeness score? Wouldn't that be a fascinating endeavor? And let's not forget about technological innovations. As we continue to push the boundaries of what is possible, our inventions become increasingly abstract and, quite frankly, strange. What if we could measure the abstractness and strangeness of these innovations, helping us to better grasp their novelty and the paradigm shifts they represent? This formula could also be used in education, helping teachers and students alike understand and navigate complex and abstract ideas. It could serve as a tool for gauging the difficulty level of different concepts, assisting in the design of teaching materials and lesson plans. Moreover, in the realm of philosophy, this formula could offer a fresh angle to explore and quantify abstract philosophical concepts, adding a new dimension to philosophical debates and discussions. In essence, this framework provides us with a new way to view human thought and creativity. By quantifying the abstractness and strangeness of concepts, objects, or phenomena, we gain a new understanding of their novelty and their distance from our everyday experiences. The potential applications of this formula are numerous and varied, limited only by our imagination and curiosity. From the sciences to the arts, from technology to education and beyond, the applications of this formula offer us a new way to explore, understand, and appreciate the world around us. The possibilities are as vast as they are exciting. While our approach is speculative, it serves as a stepping stone to a fascinating journey. Our foray into quantifying abstractness and strangeness might seem like a leap into the unknown, but it's that leap that brings us closer to understanding the world in new and intriguing ways. We started by defining abstractness as the degree to which a concept or object is removed from concrete physical experiences, and strangeness as the degree to which it deviates from common experience or expectations. These definitions, while broad, provided us with a foundation to build upon. Our proposed metrics, generalization level, familiarity index, conceptual distance, and novelty score, are attempts to capture the multifaceted nature of abstractness and strangeness. By assigning numerical values to these dimensions, we hope to create a system that allows for the measurement and comparison of these elusive qualities. We then crafted a formula, a mathematical representation of our understanding of these concepts. While it is a simplification, it is a starting point, a tool that can evolve and adapt as our understanding deepens. The calibration and testing phase is where the rubber meets the road, where we compare our mathematical model against the real world. This iterative process of testing and refining is what will ultimately shape the accuracy and reliability of our system. The potential applications of this framework are vast. From evaluating the abstractness and strangeness of new scientific theories to providing a new lens through which to view artistic movements or technological innovations, the possibilities are as boundless as the concepts we're trying to quantify. Yet, this endeavor is not without its challenges. The complexity and subjectivity inherent in measuring abstractness and strangeness cannot be understated. It's a journey that will require the collaboration of minds from various disciplines. Cognitive scientists could shed light on how our brains process abstract and strange concepts. Philosophers might provide valuable insights into the nature of these concepts. Mathematicians would play a crucial role in refining the mathematical model, and artists and writers, whose work often dwells in the realm of the abstract and strange, could provide a unique perspective that enriches our understanding. This interdisciplinary approach is not just beneficial, but necessary. The task of quantifying abstractness and strangeness is far too complex for any one field to tackle alone. It requires a collective effort, a meeting of minds, a fusion of perspectives. It's a testament to the interconnectedness of knowledge, a reminder that the pursuit of understanding is a shared endeavor. No doubt, the road ahead is filled with uncertainty and challenges, but it's also filled with the potential for discovery, for insights that could change the way we view the world. It's a journey worth embarking on, a quest that pushes the boundaries of our understanding. And so, we leave you with this thought: how strange or abstract is your world?